Hi friends, let us learn how to prove or in fact how to derive this formula of sum of squares of natural numbers. Right, 1 square plus 2 square plus 3 square plus up to n square. Right, we all know this formula n into n plus 1 into 2n plus 1 by 6. We all know this formula and very often we prove this by using mathematical induction. But the problem with mathematical induction is it assumes we already know that this is the formula and it uses or it tries to prove that it is applicable till n. Then it adds n plus 1 and it is applicable for n plus 1 also. So that's why this is valid for all n's. This is what it does. But this kind of proof is not very spectacular, right? The one who first derived this to get to this formula, we don't this formula will not come with mathematical induction. This is after someone has said that this is the formula, then mathematical induction will help, right? But to derive it for the first time, there is a genius who has done this. The that thing is not done with mathematical induction. So fundamentally, we should understand how this thing is derived. That is what it is in this session, right? Let's look at simple thing. Right. We know what is a plus b whole cube. A plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. Right. This proof has got some very clever way of using a plus b whole cube. Let us see. We know 1 cube is 1 cube. Right. What is 2 cube? 2 cube is 1 plus 1 whole cube. Right. If we expand this, this is a cube plus 3a square b. Here a is 1, b is also 1. So 3 into 1 square plus 3a into b square. b is again 1, a is again 1. So 3 into 1 plus b cube, which is 1 cube, which is again 1. Now what is 3 cube? 3 cube is 2 plus 1 whole cube. Right. What is this? If you try to expand this, a cube, which is 2 cube, plus 3 into a square b. 3 into, that is 2 square. B is anyway 1, so that's what we are ignoring. Right. Wherever b is there, we are ignoring. Right. Because we don't, with multiplication with 1, it doesn't yield us anything. So we can directly ignore. 3a square b plus 3ab square. A is again 2. 3 into 2 plus b cube, which is 1. Similarly, 4 cube is 3 plus 1 whole cube, which is 3 cube plus 3 into 3 square plus 3 into 3 plus 1. Likewise, what is n plus 1 cube? N plus 1, if you see the similarity, n plus 1 cube is n cube plus 3 into n square plus 3 into n plus 1. Beautiful. So far, so good. But what do we do with this all these cubes? Right. The genius who derived this proof, he derived it with a purpose. Right. To extract these squares. Let us see what he does. Right. He just adds one cube, all the left hand sides. Let's add all the left hand sides. Right. 1 cube plus 2 cube plus 3 cube plus 4 cube up to n plus 1 cube. Right. That is the left hand side. What is the right hand side? Again, these terms 1 cube plus 2 cube plus 3 cube up to n cube, and the first 1 cube is already there, right? 1 cube is coming twice, right? 1 cube, the first one, plus 1 cube up to n cube, plus 3 into 1 square up to n square, 3 into 1 square up to n square, plus 3 into 1 up to n, 3 into 1, 1 plus 2 plus whatever n, plus 1 coming n times. Though it is n plus 1, this one we are written separately. So that's why the remaining ones are n only. Right. This one we are writing it separately. 1 cube plus, because we are writing this separately, we are directly writing it as n times instead of n plus 1 times. Right. So now here we are. If you see, a lot of times we can cancel. Right. 1 cube up to n plus 1 cube up to n in this part up to n cube is anyway common here. Right. We can cancel this n cube till this entire part, till this entire part, right? 1 cube plus 2 cube plus up to n cube, we can directly cancel, right? Let's do that. Let's do that. Let's cancel this part and whatever this part. right? Then what will be left with? We'll be left with n plus 1 cube on the left side plus 1 cube. 1 cube is already there. This part is gone. Plus 3 into 1 square plus 2 square plus up to n square. So this is this expression 1 square plus 2 square plus up to n square. This is the sum. Let's call it as s. So 3 into s plus 3 into 1 plus 2 up to n. Right. Sum of first n natural numbers we already know. We have already proved this also. There is one video which giving this proof which we have already done. Please go through that if you haven't gone through to understand how this is, how this has come. So 3 into n plus 1 by 2, which is sum of first n natural numbers plus n. Right. Now let us again expand this n plus 1 cube. A plus b whole cube, which is a cube plus 3 a square b plus 3ab square plus 1 is equal to 1 cube plus 3 into whatever this sum, whatever the sum of squares of first n natural numbers, 3 into s plus 3n square, 3 into n plus 1, 3n square plus 3n plus n. Let us just expand this a bit. Let us try to extract s from this. 3s is equal to this entire thing minus 1. So this 1 and this 1 anyway they will get cancelled. This entire thing minus this part minus this entire part, right? So what is that? 2 we use 2. 2 into n cube, 2n cube plus 6n square plus 6n, right? That is this part. That is this part minus 3n square minus 3n minus this part 2n, right? If we just simplify this, 2n cube will remain 6n square minus 3n square is 3n square. 6n minus 3n minus 2n is 6n minus 5n, which is simple n, right? Now let's take this expression. Let's take n common. N into 2n square plus 3n plus 1, right? This is a simple quadratic equation. 2n square plus 3n plus 1. We can easily factorize this. 2n square plus 2n plus n plus 1, because the sum of these two is equal to 3n, and the product of these two coefficients 2 into 1 is equal to product of a and c, 2 into 1. So that's why we are factorizing like this. So now again taking factors, 2n into n plus 1 in the first two terms plus 1 into n plus 1 in the later two terms, right? What this gives, 2n plus 1 into n plus 1 in the inside, and this n is already there. So what is our s? So 3s is this. S becomes this 3 will go here. So the denominator will become 6. Right. That's why this is 6, this is 6, this is 6. So what is our s finally? N into 2n plus 1. Right. Into n plus 1. Which is n into n plus 1 into 2n plus 1. Whichever way we put, it doesn't matter. Right. The order doesn't matter in multiplication. Right. Hope you like this. The great German mathematician Carl Friedrich Gauss. Right, we all know Gauss, right? Gauss law. We know him with Gauss law, right? This great mathematician, he is said to have proved this, derived this formula at the age of 8. He is just a kid. At the age of 8, he is said to have proved this formula. Such a genius he was. Right? Hope you like this. This is such a wonderful proof. Thank you, guys.